Welcome everybody. We got a beautiful question. Now we have a circle. Inside the circle we got two triangles. Now OA is the radius and that is 10 units. Now this OA is the base for triangle OAD, and OA is also the base for triangle OAC. Now we are also given the height of the first triangle. Now this is the height, and that height is given as 7 units. And let me take this point as P. So dP is the height of the first triangle and it is 7 units. And we are also given the slant height. AC is the slant height of triangle number 2, OAC. Now if I were to take this point as say some Q, we are expected to find the area of O triangle OQC. So this region, this area is required. Now as I mentioned to you, this is the figure given. Of course this is the requirement, and we are also given the angle. If I were to take this as some point say R, we are given that RAO is 30 degrees. So this inclination of the slant height, and CAO is also 30 degrees. So now the requirement comes, how are we going to get this area? This requirement is needed, right? So I'm going to use the following concept in geometry. Okay, this is a geometrical rule. If two triangles have or share the same base, then their areas are in proportion to their heights. So that is an important concept that you have to know. Then the area of the first triangle, so in this case ADO, can I put it as ADO, or you can put it as OAD. So I will just start from the first vertex. So I will say DAO, area of DAO divided by the second area of CAO. Okay, that is fine because I'm taking it from the top index or the top vertex. So this ratio will be equal to H1 over H2, where H1 is the height of triangle DAO and H2 is the height of triangle CAO. So DAO and CAO. Now CQ, what is CQ? CQ is the height of triangle 2 in this case CAO. So this is going to be my H2. I don't know this H2. I have to find this H2. Now what are the things that I need to get? I need to get the area of the first triangle, and I need to get H2. If I get H2, then I will be able to find this strip and then subsequently this height. So it's little bit how would I say, you got a lot of things to do. So having given you this information, it involves a lot of geometrical concepts. So let me start off with the first one. First one is find the area of triangle 1, which is DAO. That is nothing but half times base into height. Now my base is given OA. OA is the base, so that's 10 units, and height is 7 units. Height is 7 units, that's given. So 2 into 5, this is going to be 35 square units. So area is 35 square units. So that is done. Now we have this angle being given 30 degrees. So what I wish to do is I would like to know what is this side. I want to know the height of this side or the length of this side. So I will use the cosine angle formula. So suppose you have a triangle like this, and say you have an angle A, and you know this particular length. Say, let me take it as say some ABC. This is A, this is B, this is C, and I got this angle and I need to know this side. So that side is equal to this side plus this side minus 2 times BC times cos of A, the angle between this. So using that formula, I would have A squared. A squared is this slant height, right? I need to know this. So this is equal to, I know this and this, so I'll start with 7 squared, 10 squared minus 2 times 7 into 10 into cos of 30 degrees. So this is 49 plus 100 minus 7 times 2 is 14, 14 into 10, 140. Cos of 30 is root 3 over 2. So 2 divides here 70 times. So you got 149 minus 70 times root of 3. This is my A squared. So let me take my calculator. 70. Okay, first I will extract. This calculator needs root 3 value first. So root 3 into 70. So that is 121.24. I'm just taking it like that. And from 149, so 149 minus 121.24. So I get this. So A squared is 27.76. So therefore A is root of 27.76. So you take a square root of 27.76. So what do you get? So A is equal to 5.268. So 27. So this is the value of A. So this height is given 5. I would say this height has been found. Now I don't know this. I don't know this value. Okay, let me keep it as X. Now I have got this, right? And I have got this, and I have got this. Now I can apply the Aaron's formula to find out the area of this and then extract the value of H2, or I can simply use the angle concept, opposite side by hypotenuse and then extract the value of h2. If I get h2, I know this side, then I can actually calculate this side. So let us actually use, because this is actually a right angle. You dropped a perpendicular to the radii, and that is 90 degree. But we do not know what is OQ. OQ is taken as x. Now, since I know this to be as 30 degrees, so if I were to evaluate, let me just use this space here. Sine theta. Sine theta is opposite side divided by hypotenuse. So my opposite side, the opposite side is h2. h2, my hypotenuse is 9 units. So this is sine 30 is h2 divided by 9. Sine 30 is 1 over 2. So you have h2 divided by 9. And this is going to be 9 over 2 is equal to h2. So the height is 4.5. That is the height. Okay, so that is the height. Now I want to apply Aaron's formula and also get the value of the height. Okay, so now since I've got the height, now let me use the geometrical rule. Area of DAO divided by area of CAO is equal to H1 over H2. So if I were to use that rule, so area of the first triangle divided by area of the second triangle is equal to H1 over H2. The first triangle area, we've got it as 35. So that is given. Second, I do not know. This is unknown. So let me just write it as A2. H1 height is 7 units. If you were to see the figure, this is H1, 7 units. And H2 is 4.5. So you got 35 times 4.5 divided by 7 is equal to A2. 7 divides here 5 times. So you have 4.5. 5 5s are 25, 22. So 4.5 multiplied with 5, that is 22.5. This is the second triangle area. So we have got the area of the second triangle. So this itself can be a question. This itself can be a question, right? So this is actually got. Now I need to know this segment, right? I need to know this segment. Now the issue that we have got is we do not know OQ. That is not known, but we know this and we know this. We know this value, this slant height, hypotenuse side is known, and H2 is known. So therefore we can extract this. So once I extract this, I know the area of this particular triangle because I know the height, I know the base. So that would be the simplest way to go about. So let us do this and check it out in the other method also. So what I wish to do is I would have to get this Pythagoras. I will consider CQO. So consider right triangle, right? CQO. So by Pythagoras we get, so what do we get by Pythagoras? We get h2 squared plus x squared is equal to OC squared. Now I've got OC squared, 5.27 squared. I need to go know x squared. I got h2 also. h2 is 4.5 squared. So x squared is 5.27 squared minus 4.5 squared. So we need to use the calculator. 5.27 squared, that is 27.77, minus 4.5 squared, that is 20.25. So 27.77 minus 20.25, that is giving me 7.52, and 7.52, x is equal to root of 7.52, which is approximately 2.74 units. This is the value of x. So I've got the x value, so the base is got. So if you want to find the area, so therefore area of triangle CQO is equal to half times base into height. So my base is 2.74, my height, I got the height value, height is 4.5, h2 is 4.5. So this is 2.74 multiplied with, in fact I can reduce by 2. So 2 divides here 1 time, 2 divides here 3 times, 7 times. So 1.37 multiplied with 4.5. So 1.37 multiplied with 4.5. This is going to give me 6.165. So this is the area of triangle CQO. So that is got. So this is got. Now my point is, if I were to take the entire area and subtract the second area, I need to know if I'm able to get this segment. Now x value is 2.74. So 2.74 plus 10 is 12.74. So what I wish to do is 12.74. I need to take I'm going to consider the triangle CQA, and the base being 10 plus 2.74. So that is equal to 12.74. This is the base, and the height 4.5 is the height. H2, this H2 value 4.5. So the area of triangle CQA is equal to half times base into height. So the base is 12.74 and the height is 4.5. This is 6.37. So 6.37 multiplied with 4.5. So 6.37 multiplied with 4.5. This gives me 28.665. This is the area. Now area, if from this area I want to subtract, the required area is equal to, from this area I subtract the area of the second triangle. So 28.665 minus, let me get the area of the second triangle, 22.5. 22.5. So that is the area that we calculated. So let me show you. So this is the area, 22.5. So if I were to subtract that, let me, 28.665 minus 22.5, I get a value of 6.165. So this is the required area. Now you see this 6.165, 6.165. So that is agreed. So in the first case, So this value that we have got and the subsequent entire base and the area that has been calculated using the base and the height clearly extracts us the requirement, or I would say clearly ascertains that what we have done is absolutely correct. So this is an interesting question, and you can go through this and give your comments, give your insights specifically about this beautiful property. So I have used this lovely geometry property and we have got a lovely result. So please like, share and subscribe to our channel until we meet again. Thank you.